Today we're going to walk through how we can add gRPC support to your ServiceStack server and how to simplify your client integration. gRPC is a high-performance, language-agnostic remote procedure call or RPC framework that has well-defined message contracts using the .proto files and supports standard client-server calls as well as bidirectional streaming. The use of protobuf for serialization and wide language support for server and client implementations has made it a popular option for developers starting new projects. ServiceStack has first-class gRPC support and offers an extremely powerful advantage. Your ServiceStack services are gRPC services. Today we'll walk through exactly what that means by first showing a minimal implementation of adding gRPC support to a Hello World service, and then we'll also walk through using gRPC alongside high-level ServiceStack features like autoquery and autogen. This will highlight what it means to share service implementations between standard HTTP and message queue services right alongside with gRPC. Before we get started, we'll need to make sure we have a few things installed. You'll want the latest version of the .NET 5 SDK, the ServiceStack X tool, and any development environment that supports a gRPC client. Today we'll be using IntelliJ to write a simple Dart console application that connects to our ServiceStack server. This will demonstrate the interoperability of ServiceStack with gRPC support with any standard gRPC clients. To kick things off, we'll start by creating a new GitHub repository and generate a new project using the standard web template from the ServiceStack X tool. To do this, we can clone the newly created repository, navigate into the root directory, and run the command xnew-web space gRPC Northwind demo, where web is the name of the template and gRPC Northwind demo is the name of our project. If you don't have the ServiceStack X tool installed, you can install it using the command .NET tool install -gx. Opening our new application, we'll first show getting gRPC support added and working with the default Hello service in the template. To add gRPC support to a ServiceStack project, we can use the xtools mix command, which mixes in templated code into the existing ServiceStack projects. In this case, we'll run the command xmix space gRPC in the root of our repository. Looking at our project, we can see two files have changed. A new file called configure.grpc.cs and our apphost project file has been updated to include the package reference of servicestack.extensions. Running this project, we can see our Hello service working as normal, and looking at the ServiceStack metadata page, we'll see a reference to gRPC in the plugin links called grpc.proto APIs. .proto files are the way gRPC defines its typed message contracts and how standard gRPC clients know how to communicate with gRPC services. Clicking this link takes us to the /types/proto path and shows us a proto file defining some types, but the hello type is missing. Just like ServiceStack's standard support for the protobuf format, gRPC needs the data contract and data member attributes added to the data transfer object classes, or DTOs. This is because the services will be using the protobuf format for serialization, which is generally the default for any gRPC services. The order property on the data member attribute tells the protobuf serializer the field name to use for each property in the message, represented by each ServiceStack DTO class. Once these attributes are added to our request and response classes, we can rerun our application and refresh the types/proto URL to see our Hello service is now represented in the message contracts. Swapping over to IntelliJ with an empty Dart console application, we want to be able to communicate with our new Hello service via a native gRPC client. To set up our Dart client with the required dependencies, we'll need to update the pubspec.yaml file to include fixnum, async, protobuf, and gRPC as dependencies. At this point, we could pull down the .proto file from our ServiceStack instance, use protocgen-dart or another tool to generate our client, and go from there. However, the ServiceStack X tool handles this generation for our client with the command x-proto-dart, the location of your ServiceStack instance, and then specifying an out directory. It saves the services.proto file and generates the client code that we can import into our main.dart file. From our generated code, we want to import your package name, services.pb.dart, and services.pbgrpc.dart. Once imported, we can instantiate our gRPC client with the host of our ServiceStack server and the port you are using, which brings us to something else your server will need. gRPC requires HTTP2, so while our normal ServiceStack HTTP services are available on port 5001 with TLS defaulting to HTTP 1.1, we'll want to make sure our application is set up with a secure and non-secure port for gRPC as well. In your ServiceStack project, we can configure Kestrel to have different endpoints. Here we'll define HTTPS, gRPC secure, and gRPC insecure as shown. Running your ServiceStack application again and going back to our Dart client, we can finish instantiating our client. A part of generated clients for gRPC and other RPC frameworks is that the syntax for fetching data looks a lot like a local procedure call. So when we are looking at the autocomplete from our IDE, we can see a list of all the remote procedures available to our client. The reason there are multiple methods here for the hello service is because the server uses the any verb for the method, meaning that get, put, post, and delete are valid verbs to call this single service method. Creating an instance of our hello message for our client and outputting the response, we can see that our call was successful. To highlight further the advantages of sharing your service code between HTTP, message queue, and gRPC, we're going to utilize a ServiceStack feature called AutoQuery along with AutoGen. The AutoGen feature for AutoQuery will take a connection to your database, in this case a SQLite file, and generate ServiceStack services at runtime. And since ServiceStack services are gRPC services, we can run our application again and see our updated .proto file. Jumping back to our Dart client and using the ServiceStack X tool to update our generated client, we can see all the new services available in our autocomplete. Changing our client to fetch order details, we can see data from our database via the AutoQuery services output to our console. ServiceStack gives you the best of both worlds when it comes to building services that need to have gRPC support. You don't have to maintain a separate plain text.proto file, and instead let your code-first ServiceStack DTOs define what messages and methods your gRPC services support. And from the client side, the .proto file is generated and available from our running ServiceStack server. The X tool makes it simple to get started and update your client based on any changes in your server integration. This gives us a great developer experience for both working on the ServiceStack server as well as integrating with native gRPC client libraries. That's it for this video. I hope this has shown something useful, and thanks for watching.